Well, hi class, welcome back to Algebra. Most of you have been experienced with these videos before, but we have some new kids in our class this year. We have Emily Huckins, Dara Hayes, and Leah Witten will be joining us this year for Algebra 2. So this is a video, it's not of any specific lesson. It is from problem set B, and it's on sectors of a circle. This is something I'm not sure that you're familiar with. When Jonathan posted the problem from lesson 1, number 5, I realized that you might not know how to find sectors of the areas of sectors or the arc length of sectors of a circle. So I thought I'd do this short video, hopefully it'll be short, about how to find area of a sector and the arc length of a sector. So, a sector is the area when two radii connect the endpoints of the arc to the center of a circle. So, like a sector, let me just draw a quick sector here. Like if we're going to have a sector, if I'm going to put a sector in this circle, it would look like this. This would be a sector, whoops, that's not what a sector looks like. Hold on a sec. So I'm going to erase this in a minute, but a sector of a circle would be something like this, and then it would be filled in like that. That's a sector of a circle. It goes from the center. It's two radii that connect out towards the end towards the circle. So we're going to find the area of these. But first, I want to review a couple things, like knowing some things you need to know is that there are 360 degrees in a circle. That's the first thing you need to know. The second thing you need to know is how to find the area of a circle. The area of a circle, in case you forget, is pi r squared. So if we have a radii of 4 in this circle, we can easily find the area because you would just take 4 squared, so that would be 16. Pi would be the area of the circle. And you'll notice in the book, I already have it in there, in the book they typically would take and multiply 16 times 3.14 and they would give you an answer without pi in it. They use 3.14, but feel free to use your calculator and you can just push the pi button on your calculator. You're going to get a slightly different answer, but that's okay. Alright, so that's a whole circle. It's finding the area of the whole circle. The whole circle is 360 degrees. If we want to find the area of a half a circle, so we're working our way down to doing a little sector. We're getting a little bit smaller and smaller. A half a circle, well, you would say, duh, a half a circle would be half of 16 pi, so half of this circle, if the radius is 4, it would be, half of that would be 8 pi. And that's easy to think about, but what we're really doing is we have the degree is 180 degrees. We have 180 degrees out of 360 degrees, so that would be 1/2 of a circle. So you can tell what part of a circle it is by taking the degrees and putting it over the total number of the degrees in a circle, which is 360. Let's move on. Okay, now I divided it into, it looks more like a sector now, doesn't it? I divided it 1/4 of a circle. And we can see 1/4 of a circle, the degree would be 90 degrees. This is called a central angle. A central angle goes from the center to, and its endpoints end on the circle. So when you have a central angle, whatever the degree of the central angle, its arc also has the same degree, which would be 90 degrees. So this obviously, once again, would be 1/4 of a circle. So we would take our 16 pi and we divide it by 4 and we get 4 pi. But let's say it's not so cut and dry. 90 degrees we know is 1/4 of a circle. In order to find the part of the circle it is, we would put 90 over the total number of degrees in a circle is 360. So the total number of the total part of the circle would be 1/4 of the circle. So that tells us we're going to take 1/4 of the total area of the circle. So we would take 1/4 times the total area, which we said was 16 pi, and you can see that the area of the sector would be 4 pi. Alright, I did all of this just to show you how to figure this out in case you can't remember the formula later on. So let's try some sectors. What if this was some random thing like 27 degrees? Let's go over here where I did this already. So we're going to do some random sectors. So the question is, what is the area of this random sector? So we want to find this red area. The first thing you're going to do when you're finding areas of a sector is you're going to find the area of the entire circle. And then we're going to find out what fractional part this little sector is. So if we're going to find the area of the circle, we have area equals pi r squared. The radius is 6 here. So it would be r squared would be 36 pi. So the area of the circle is 36 pi, and in the book they actually multiply that out and they get 113. And it's in meters, so it'd be meters squared. Make sure you always include your units when you're doing problems with units. Okay, so the area of the circle is 113 meters squared, but we don't want the whole area of the circle. We just want this little fractional part of the circle. And to figure out the fractional part, remember how we did it with the 90 degrees? You would take 27 over 300, the total degrees of a circle is 360 degrees. And if we would multiply that together on our calculator, we would get 8.48 meters squared. So to find areas of sectors, all you do is you find the area of the circle and multiply it by the fractional part that is colored in. Now something else that we're going to do is we're going to find the length of this arc. This is called an arc of the circle. And it's the same thing, only this time we're not going to deal with the area, the inside. We're dealing with the circumference. So hopefully you remember the formula for circumference. So this time you can find the area of the sector, and we can also find the arc length of the sector. So you have to know the circumference would be 2 pi r. So the circumference of this circle would be 2 times 6 would be 12 pi. And if you want to find the arc length, you have to take that times the fractional part. Remember, this is going to be, if this is 27, this is going to be 27 degrees. This is degrees, but we want length. We want to know how many meters it is, not how many degrees it is. So we would take 27, this times 27 over 360, and that will give us our answer. Alright, let's do one more real quick. This one says the radius of a circle is 10 centimeters, right here. Find the length of the 45-degree arc and the area of a 45-degree sector. So first thing they want us to do is to find the length of this arc. This arc is not in the inside, so we're going to deal with the circumference. So what they did in the book was they found the area of the circle. Remember, it's pi r squared, so this would be pi r squared would be 10 squared, and so the area of the circle would be 100 pi, or 314 centimeters squared. The first thing they want us to do, though, is to find the length of the arc. So we have to know the circumference as well. So the circumference is 2 pi r, and that would end up being 62.8 centimeters. So we have the area of the whole circle and the circumference of the whole circle, but we don't want the whole circle. We want just this little arc, and we want just the inside, which would be the area. So if we're going to find the area of the sector, we know that the fraction that we're going to be dealing with is 45 over 360. That's the fraction that of the circle that we're going to multiply the area by to get the area inside, and we're also going to take this fraction and multiply right here the circumference by to get just the arc. So if you want just the arc, just remember it's the circumference times the fraction of the circumference, and to get the area it's the area of the whole circle times the fraction of the circle that's colored in. So hopefully that helps. I went really fast to cover this, so if you have any more questions, we can go over this in class just coming up this Thursday. Let me know if you have questions. Thanks.